Okay, so good day everyone. My name is Ian Gabriel Dizon from BECE 3G, and this subject is for mechanics, dynamics of rigid bodies, and I am going to discuss example number 1 from relative velocity. So let's begin. Example number 1, the wheel of radius r is equal to 300 millimeters rolls to the right without slipping and has a velocity of v sub o is equal to 3 meters per second of its center O. Calculate the velocity of point A on the wheel for the instant represented. So we have here our figure for example number 1. So as you can see, we have a radius of 300 millimeters and this is our point O. So this is point O. Point A is located here with a r sub O is equal to 200 millimeters. And we also have a theta of 30 degrees. So in order to find v sub a, the equation that we're going to use is v sub a is equal to v sub o plus v of a and o. Now, in order to use this first, we must find first the angular velocity. So how are we going to find that? Omega is equal to v sub o over r. So we have a value of initial velocity or v sub o which is equal to 3 meters per second and an r of 300 millimeters. So let's just substitute. So v sub o over r, therefore 3 over 0.3. So calculating 3 divided by 0.3, we have 10. Our angular velocity is equal to 10 radians per second. Now this the value of 10 rad per second will be negative because of the right hand rule, so we're going to put a negative sign beside it. After solving the angular sorry, this is not the angular velocity sign, no? It's angular acceleration. So this is omega, sorry, my bad. This is for angular velocity. Now that we solved for the angular velocity, we can now solve for the v of a and o. So the formula that we are going to use for that is v of a and o is equal to r sub o multiplied by theta prime. Now from the previous lessons as examples that I have explained earlier that theta prime is equal to the angular position or the omega. Since we have the value of omega obtained earlier, we can substitute it, and since we have a value of r sub o, we can just substitute and solve for the value of v of a and o. So 0.2 multiplied by negative 10. Therefore v of a and o is equal to negative 2 meters per second. So by solving v sub a and o, we can determine, or we can say that we can use a parallelogram method because we can draw a paragram at this point. So let's just illustrate. Let's say this is a, then okay, so this is v sub o, then this is v of a and o, therefore this is v of a. So we can use cosine law, the cosine law. So the formula that we are going to use in order to solve for the v sub a is va squared is equal to vo squared plus v of a and o squared minus 2 multiplied by v of o multiplied by v of a and o cosine 60 degrees. So, why 60 degrees? Ito yon, yung 30 binaliktad lang, kaya naging 60 degrees. So, substitute all the given values. We have for v sub o, 3 squared plus negative 2 squared minus 2, 3, negative 2 cosine 60 degrees. Solving, we will have a final answer, or not yet because we're going to square it since VA has x squared along with it. Solving this first, 3 squared plus negative 2 squared minus 2, 3, negative 2 cosine 60. We have 19. Square both sides. The final answer will be VA is equal to square root of 19 is equal to 4.3588, or we can simplify it as 4.36 meters per second. So that is the value of V sub A, and that is the answer for example number 1.